Hello everyone, welcome to another linked list problem. Let's solve removing duplicates from a sorted list. By the way, I'm using a new drawing software, so I apologize if there are any glitches and stuff. I'm still trying to get comfortable using it. So let's jump right into the question. So we can see that we are given the edge, of course, of a linked list, but it is a sorted linked list, as we can see from um, the illustration given here. So it's a sorted list, right? And we want to remove all of the duplicates. We can see that the output given is 1, 2, because 1 is a duplicate. And so that is what we want to do. And we want to return the linked list sorted as well. But that should not be any problem really, because once we remove the duplicates, right, it's already sorted, so it is still going to be sorted. So let's give ourselves some room and jump right into the illustration. So we'll be using two different methods to solve this. The intuitive, or I won't say intuitive, but it's my go-to method when I have to deal with any form of finding duplicates, right? And if you've watched any of my videos, you know that is the set method really. So basically we know that we have a linked list, and for any linked list problem we have to traverse. It is impossible not to traverse, and while traversing we are kind of like storing our sets, right? We are storing visited values, and if at any point here we have a duplicate value, we just check our set. Have we seen this number before? And yes, we have seen it here. So what do? We just skip over this number. We know that it's not going to look like this, right? Because we are giving a sorted list. So it even helps us that we are giving 1, 1, 2, and 3, right? So as we are traversing the entire list, we are storing. We store 1, and then we know that we can check the next number here, right? We can check the next number here to see if we've already seen that number before, and yes we have. So we can just update our next pointer to go from here to here. We are skipping over this one which we have previously visited, and then we can just do that for the entire list. Now I'm going to give clear out the entire space because this looks a lot like doodling. But I promise I'm not doodling. I'm just trying to get comfortable with the drawing software, right? All right, so let's try this again. So the first thing that we want to do, this is the first method. You want to declare an auxiliary data structure. That's a second data structure. In my case, I'm going to use set because set is really good for keeping track of duplicates. But in your instance, you can use anyone that you want to really. And then we have our linked list, right? We have our linked list, and we are kind of we're traversing, right? As we do with every linked list problem, we have to traverse. So we go from here, we go here, but as we traverse, we check, is in our set data structure? No, it's not. And if it is not, what do? We add it to our set data structure. So now that we've added 1 to our data structure, we can go ahead to the next item in the linked list and we check again. But we see that this is already in the data structure. So what do we do in the set data structure? So what do? We skip over this one, right? We just skip over it. And how do we skip over numbers in our linked list? We skip over numbers by breaking the pointers to it. If we get rid of the pointer pointing to it and the pointer pointing after it, it doesn't exist anymore, right? So we just say that okay, 1 no longer points to 1 here, 1 now points to 2, right? 1 points to 2 here, and we are good. So that is what we want to do for our set data structure. But as you may have noticed, the set data structure is going to use a O of n space complexity, because basically the set data structure is an extra space, right? And since we are traversing the entire length, the entire input given, we are also going to have a linear time operation. Now, can we do this any better? And yes, we can, and that is why there is a second solution, right, to see if we can do this any better. So we are given one, sorry, this is too big. We need to give ourselves more room. 1 1 2 3, right? Rather than storing this in a data structure, this is already sorted. We really do not need to store anything in a data structure. We can just check if the first item is equal to the second item, it's equal to the next item, it's equal to the third item. And if at any point they are, like literally they're already sorted, right? So duplicates will be close to each other. There is no how they can be scattered. Set to be more effective if it is not a sorted list, right? Because now we are traversing the entire thing and we do not know where duplicates might be, but we already know where the duplicates might be. They are right next to each other. So literally, while traversal, we are just comparing if the current value that we are on is equal to the value of the next element, and if it is, again, we can just say that okay, you are equal, we already have you, so we are removing your pointer, right? And we are just changing the direction to the next item after the duplicate. So this is what the second code is going to be. And since we are not using any extra data structure, we are just going to solve this in a constant space and a linear time. All right, let's jump right into the code. By the way, if you are not yet subscribed to my channel, please subscribe. It helps to support the channel. And if you do enjoy the video, please give it a thumbs up so that YouTube algorithm basically can share it to similar people, since some people are liking it. Now let's solve this problem using the set data structure, and we'll be using 2 pointers here, but I'm kind of like going to solve it and show you why we will need to use 2 pointers while we're solving the problem. So first, as you might be used to, we initialize our extra data structure, and we also create a pointer to our head element. And while current is not known, basically we want to check that if duplicates, if current or if the value is in duplicate, then what do we want to do? Basically, we're saying that we have 1 2 1 and 2. So we're saying that if 1 is inside of this set, then what do we want to do? We want to allow our previous pointer, right, to point to the next pointer of this. So we need to have something like previous dot next to point to current dot next. Else we just want to add our duplicates, right? We just want to add our value to our sets that we've not visited. In the first iteration, we do not have 1 in our data structure yet, so it's going to get added. But in the second iteration, we definitely do. So how do we update? Like, okay, so we don't want you anymore. We want this first one, we want its pointer to point to this next. That's this previous of this current value 1 to point to this next value. So what do we do? That means we need an extra an extra pointer rather, to keep track of this previous. And now this might change the direction of our code a little bit, because now we have to have a previous that points to the head and a current that points to the head to next, right? So we have 1 pointer at the year, 1 pointer here. This pointer keeps track of our previous. The current is the next value, it's keeping track of where we are currently. And let's add our previous value. So what are we doing here? Now that we've already declared that we have 2 pointers, 1 pointing to the previous year, that's the head, that's from line 9, and 1 pointing to the next value here, then we want to kind of like keep this first value in our set data structure. Now we can start our iteration from the next, right? So now we are just comparing the next to this value we already have this first one. That's what we're doing in line 10. We already have the head value stored in our set data structure. Then we want to start our iteration from the next. Remember that current is now set to head.next. So we want to add our second. We want to start our iteration from this value. And we're checking if this value, which is now our current, because we've updated our current to head.next, we want to check if it is duplicate, and in this instance it is going to be in duplicate because we already saved this. If it is in duplicate, then we want to update this pointer previous.next to current.next. Recall that they are both pointing to the same head. So if we manipulate previous, we're obviously manipulating current. So but just that previous is keeping track of a different element in the same linked list. So it's not like they are two separate lists, they're actually the same list but pointing on different elements in the list. So we want to set previous.next to current.next because current.next is before previous.next. So previous.next will now be current.next, which is going to point to 2. I hope this is not too confusing. And then if it is not in our set data structure, then we can just add it to our set data structure. We also want to shift our previous, right? If current value is not a duplicate, we want to shift our previous pointer. And so that we're not stuck in an endless loop, let's also shift our current pointer, and then we can just return head. Now let's run this code. We run this code, submit it, and this should run fine. Oh, it doesn't. Okay, it doesn't because it is possible that we are giving an empty head, right? So we need to catch that not base case, really. We need to catch that edge case. So if not head, then we just want to return head. So let's try to submit this again. And yeah, cool. Now let's solve this using just comparing pointers, right? Since they are sorted and they are next to each other, the duplicates will obviously be next to each other. We can just compare every iteration with its next iteration. Now we're going to declare a variable current that is pointing to the head, and we're going to say that while current and current dot next, while there is a current and there is a current dot next, recall that we want to compare current and current dot next. So we want to compare both their values, right? We want to compare both these values, so we have to be sure that current dot next actually exists. So if current dot value is equal to current dot next dot value, then we want to set current dot next to the next of current dot next, and I want to continue this iteration. Otherwise, we don't want to be caught in an endless loop, and we want to shift our pointers, and then we can just go ahead and return our head. Let me just make this risky and try to submit it without running the base the example test case is given. Alright, that was a bad idea because I use an assignment operator instead of the comparison operator, and hopefully that's all the error we get in this code walkthrough. And yes, thankfully it is. Now that's the end of the video. I hope you subscribe so that you can be updated when I make more videos about solving data structures and algorithm or any other tutorials really. Thank you for watching. Bye.